In this video, I'm going to cover some problems that you might see on the College Algebra CLEP exam. And if you want to get an A in your class, remember to help support this channel by hitting the subscribe button. Now this first one deals with rational expressions. You get one fraction divided by another. To make this easier, I want to change it into a multiplication problem. And you do that by, first having the top expression. So that's x squared minus 9 over x plus 2. Then I want to multiply it by the reciprocal of the denominator. So that'd be x minus 2 over x minus 3. And simply put, the reciprocal just means to flip it over. X minus 3 was on top here, but now it's going to be on the bottom of this fraction. X minus 2 was on the bottom, and now it's going to be on the top. Alright, so we end up with x squared minus 9 over x plus 2 times x minus 2 over x minus 3. Now with rational expressions, we always want to put it in the lowest term. So we want to be able to factor out what we can and reduce what we can. When I see the x squared minus 9, I can see that's a difference of two squares. X squared minus 3 squared. Okay, and that becomes x plus 3 times x minus 3. Keep the denominator. Over here is still x minus 2 over x minus 3. Now if I see if anything's on top or bottom that's in common, I can reduce it. So I can see this x minus 3 on top, and on bottom that reduces down to 1, so they cancel each other out. So you're left with x plus 3 on top here times x minus 2 all over x plus 2. So that will be reducing this rational expression. Now on this second problem, as for any positive integer n plus 1 factorial divided by n factorial minus 1 equals. So we want to reduce this, put in its lowest terms. Now remember factorial, if I had 4 factorial, let's say, that means starting at 4, multiply 4 times 3 times 2 times 1. Starting at the 4, going all the way down to 1, multiplying those all together. So 4 times 3 is 12, 12 times 2 is 24, times 1, still 24. Okay. Now if I have n plus 1 factorial, that'll be n plus 1 times n, so I'm basically subtracting 1 each time, times n minus 1 times n minus 2, and down all the way down the line until you get to 1. Okay, so we got n factorial on the bottom. I can kind of notice that I can take out the n plus 1. If I do that, I have the rest here, n all the way down to 1, which would be n factorial. So n plus 1 times n factorial, that's still the same thing. I just took out the n plus 1 over n factorial minus n. So if I do that, the n factorials cancel out, gives you 1, leaving with just the n plus 1. Then bring down the minus n minus n adds up to 0, just leaving you with 1. So this expression simplifies down to 1. So in this problem it says if log base x of 5 equals 2, what is the value of x? Okay, so our goal is to figure out what the value of x is that makes this true. Okay, so remember, if you remember log form, log base b of x equals y. Okay, so that's logarithmic form. Exponential form is b to y power equals x. So we need to know those two expressions, two formulas. So I'm going to rewrite what we have, log base x of 5 equals 2 in exponential form. Okay, so the base is the x in our case here, raised to the y power, which is 2 in this case, equals 5. Now I got x squared equals 5. I want to solve for x, so I take the square root of both sides. Alright, so x equals, and normally it's the plus or minus square root of 5. Okay, because square root of 5 squared gives you 5, and negative square root of 5 squared also gives you 5. Now if we look here, we're dealing with logarithms, so in this case x can't be negative, so we'll end up, if you look at the change of base problem, you have log base b of a. You rewrite that as log base 10 of a divided by log base 10 of b. And we use this because our calculator doesn't have, log base square root of 5. It only has log base 10, which you see as log in your calculator, and log base e, as you see as ln, the natural log. So in this case, you can't take log base 10 of negative square root of 5, because you can't take a logarithm of a negative number. So in this case, only the square root of 5 would work out. Alright, so log base square root of 5 of 5 equals 2. Or in exponential form is square root of 5 squared equals 5. Alright, so in this next problem we have when 3 plus 4i divided by 2 plus I is expressed in the form of a plus bi, what is the value of a? Okay, so when we're dealing with I, it's an imaginary number. Remember, I is equal to the square root of negative 1. And since there's really no real number that's, you can't take the square root of, if I said negative 25, there's no number squared that will give you negative 25. We know a square root of 25 is just 5 times 5. But when you're dealing with a negative, we have to break up the 25 by itself and the negative 1. So we got square root of 25 times the square root of negative 1. Square root of 25 is 5. And since we can't take the square root of a negative number, we denote that as I. So in this case, negative square root of the square root of negative 25. The square root of negative 25 would be 5i. Now when we have an expression like this, the 3 plus 4i plus 2 plus I, we want it in the form of a plus bi. What we need to do is take the conjugate of the top and bottom. So the conjugate of 2 plus I would be 2 minus I. When we do that, it ends up getting rid of the imaginary number on the bottom, and that's our goal. So I'm going to take my expression here, 3 plus 4i, divided by 2 plus I. I'm going to multiply top and bottom by 2 minus I. And if I had originally 2 minus I instead of 2 plus I, the conjugate would just be changing the sign in the middle. So the conjugate of 2 minus I would be 2 plus I. Alright, so when I do that, I'm going to do the bottom first. So you basically have these two together, multiply them together. You can use your FOIL method to multiply these out. 2 times 2 is 4. 2 times negative I is negative 2i. I times 2 is plus 2i. And then I times negative I is negative I squared. And on top, we got 3 times 2 is 6. 3 times negative I is negative 3i. 4i times 2 is 8i. And then 4i times negative I is negative 4i squared. Now on the bottom we got 4 minus 2i plus 2i minus I squared. So the minus 2i plus 2i adds up to 0, so that goes away. So I'm left with 4 minus I squared. On the top, I have 6, negative 3i plus 8i gives you positive 5i. And then minus I squared. And now I squared is what? Square root of negative 1 squared, which is going to give you, it's defined as negative 1. So I'm going to change the I squareds to negative 1. So it ends up being 4 times negative 1. And then 4 minus negative 1 on the bottom. So that's going to give me 6 plus 4 on top of the 5i. So that's 10 plus 5i. And then 4 minus a negative 1, that reduces to 4 plus 1, or just 5. Okay, so now I have 10 plus 5i divided by 5. And I can see I can reduce this a little bit more. Each of them, each number is divisible by 5. So 10 divided by 5 is 2. 5 divided by 5 is 1. Leaves me with 1i, or just I. And then the bottom 5 divided by 5 is 1. Anything divided by 1 is just itself, so just 2 plus 1i. And we wanted to know what was the a value, so that's the real part of it. Remember, this is the real part of the number, and this is the imaginary part of the number. So you got a real part and an imaginary part. Our a is going to be 2. Alright, this next problem says, what are all the real values of x? We have 2 divided by 3 minus x equals 1/3 minus 1 over x. Okay, so our goal here is to find out what value of x makes this equation true. So So when you have fractions and your variables in the denominator, you need to find out a common denominator and multiply every term by that to get rid of the x term in the denominator. So our denominators so far are 3 minus x, 3, and x. So our common denominator would be 3x times 3 minus x. Now none of these three have anything in common, so the common denominator had to be all these three multiplied together. Okay, so I'm going to multiply the first fraction by 3x times 3 minus x. If I do that, the 3 minus x will cancel out, leaving with the 2 times the 3x. And then if I multiply the 1/3 times 3x times 3 minus x, the 3 is going to cancel out, leaving with just the x times 3 minus x. And if I multiply the 3x times 3 minus x times the 1 here, the x will cancel out, leaving you with just the 3 times 3 minus x. Now if I multiply this out, 2 times 3x gives you 6x. X times 3 is 3x. X times negative x is negative x squared. And then negative 3 times 3 is negative 9. And negative 3 times negative x is plus 3x. Now my goal here is to get everything to the same side so I can try to solve for x. So I'm going to look on this right side. I got 3x plus 3x. So I can combine those to 6x. And I get negative x squared and minus 9. I bring down the 6x. I want to move the 6x to the other side. So I'm going to subtract 6x from both sides. So I'm left with 0 equals negative x squared minus 9. And typically I like to have a positive x squared term, so I'm going to multiply everything by negative 1. That's going to give me 0 equals x squared plus 9. Now if I look at this, there's no way I can factor it. This is not a difference of two squares, so there's no way we can have no x term. If I try to do the quadratic formula, that's negative b plus or minus b squared minus 4 times a times c divided by 2a. Now if I just look at the square root part, our b, which is the coefficient of the x term, remember ax squared plus bx plus c. We don't have a x term here, so that's 0. 0 squared minus 4, our a is 1, our c is 9. So we end up with 0 minus 36, or square root of negative 36. Okay, so that's going to end up giving us an imaginary number, 6i. But here is asking for real values of x. So in this case, we do not have any real values of x, so this is no solution.